So if the data come from a normal distribution, then the JB test statistic has a chi-squared distribution with 2 degrees of freedom. And this is really helpful because we can use the right-tailed chi-squared distribution with 2 degrees of freedom to calculate the p-value from the Jarque-Bera test statistic because we're testing for the normal distribution. Which means in Excel and ENG sheets, it's as simple as using a chi-sq.dist.rt of your JB and 2 degrees of freedom. But again, we're doing this brute force. So let's see what the formula we can use is. So the right-tailed p-value is going to be 1 minus the CDF p-value, 1 minus the left-tailed p-value. And something really cool is that the cumulative distribution function of the chi-squared distribution with 2 degrees of freedom follows this incredibly simple equation, 1 minus exp of minus x over 2. So again, CDF is our cumulative distribution function for the chi-squared distribution. X is the value we're going to evaluate the probability of, and df is our degrees of freedom. So if we plug in that CDF into our Jarque-Bera p-value equation, we see that p equals 1 minus, in parentheses, 1 minus exp of minus jb over 2. So if we distribute out that negative 1 and we add it all up, we find out that the 1's cancel each other out and that negative in front of exp also cancels out, which means that the p-value associated with the Jarque-Bera test statistic is p equals exp of negative jb over 2, an incredibly simple function. It's almost easier than actually using the chi-square.dist.rt because you have to type out more letters in order to do the chi-sq.dist. So kind of a cool, actually an incredibly cool simplification of calculating a p-value.